In Episode 1, we learned that reasoning has 3 pillars. In Episode 2, we went deep into the first, deduction, Aristotle's gift, the architecture of certainty. Today, we move to the second pillar, one that built modern science, one that was shattered in a single afternoon, one that changed the way we understand knowledge itself. This is the story of induction and of the black swan that broke it. Welcome back to Deductive Minds. Today, inductive reasoning, how it works, why it matters, where it breaks, and how to use it wisely in your everyday thinking. Inductive reasoning works like this. You observe something, then you observe it again and again. And from that accumulation of specific observations, you draw a general conclusion. This is not certainty. This is pattern recognition. This is probability made systematic. And it is the engine that drives almost everything we call science. To understand induction deeply, we need to meet a man who made philosophers deeply uncomfortable. David Hume, Scottish philosopher. 1788. Hume asked a question that seems simple and is actually devastating. Just because something has always happened before, how do we know it will happen again? You have seen the sun rise every morning of your life. But does that guarantee it will rise tomorrow? Logically, no. It is simply what has always happened. Hume called this the problem of induction, and no one has ever fully solved it. For centuries, Europeans observed swans, thousands of them, tens of thousands, every single one white. The conclusion seemed ironclad. All swans are white. This was induction at its most confident, a mountain of evidence, a universal law derived from observation. Naturalists wrote it into textbooks. Scientists treated it as settled fact. And then, 1097, Dutch explorer Willem de Vlaming arrives on the western coast of Australia. And there, in the river water, a swan. Black, one bird, one observation. Centuries of certainty, gone. The universal law, all swans are white, was not weakened by this discovery. It was destroyed. This is the fundamental fragility of induction. No matter how many confirming observations you accumulate, a single counterexample can collapse the entire structure. The black swan problem led to one of the most important ideas in the philosophy of science. Karl Popper, Vienna, 1934. Popper argued that the strength of a scientific theory does not come from how many times it has been confirmed. It comes from how easily it could be proven wrong, and has not been. He called this falsifiability. A good scientific theory is not one that explains everything. It is one that makes specific predictions, predictions that could, in principle, be false. If a theory cannot be proven wrong, it is not science. It is belief. You use induction every single day. When you trust a restaurant because it has never let you down, when you assume a friend will be on time because they always have been, when you invest in something because its past performance has been strong, these are inductive leaps, and they are reasonable. Induction is not wrong. It is necessary. Without it, we could not function. We could not build science. We could not plan for tomorrow. But it must always be held lightly because the black swan is always possible. First, practical exercise. Audit your assumptions. Take one belief you hold with complete confidence, something you have never questioned because it has always been true. Now ask, what would a black swan look like here? What single piece of evidence would destroy this belief? If you cannot answer that question, you are not holding a rational belief. You are holding a blind one. Popper would say, make your beliefs falsifiable. Know in advance what would change your mind. That is intellectual honesty. That is how induction becomes a tool instead of a trap. Second practical exercise. When you are about to make a decision based on past patterns, ask yourself 3 questions. 1. How many observations is this pattern based on? 10 or 10,000? 2. How diverse are those observations? Or do they all come from the same conditions? 3. What has changed that might make the past a poor guide to the future? The stronger your inductive base, the more varied your evidence, the longer the pattern, the more different the conditions, the more you can trust it. But never absolutely, never without a contingency. The black swan does not announce itself. Third practical exercise, and this one is urgent. Every day, we are bombarded with inductive claims. Studies show that, research confirms that, data suggests that. Before you accept these claims, ask 4 questions. How large was the sample? How long was the study? Has it been replicated? Who funded it? A study of 48 people over 2 weeks is not the same as a study of 40,000 people over 40 years. Both are induction, but they are not equal. Train yourself to see the quality of the evidence, not just the confidence of the conclusion. We must not leave induction diminished. Despite its fragility, induction built everything. Every vaccine came from inductive patterns. Every engineering achievement built on accumulated evidence. Every map of the human body drawn from repeated observation. The Wright brothers did not deduce that flight was possible. They observed, they tested, they iterated. They built knowledge inductively, piece by piece, failure by failure, until the pattern held. Induction is powerful. It is simply not certain. And knowing the difference between powerful and certain is one of the sharpest edges a mind can have. Let us lock this in. Induction reasons from many specific observations to a general conclusion. Its power. It builds knowledge from experience. Its limit? It is always vulnerable to the next observation. David Hume showed us we can never be certain. Karl Popper showed us how to hold beliefs rationally by knowing what would falsify them. The black swan is always out there. The wisest minds are always watching for it. Next episode, we arrive at the 3rd pillar, the most powerful, the most misunderstood, the one that Sherlock Holmes actually uses, abduction. The reasoning from anomaly to best explanation. The method of the detective, the doctor, the scientist, and the one that, unlike deduction, thrives in uncertainty and, unlike induction, can move from a single clue to a world-changing conclusion. That is where we go next. Thank you for being here. If induction and the black swan made you think differently about how you form beliefs, then this episode did its job. Subscribe to Deductive Minds so you never miss what comes next. Leave a like if this gave you something to work with. It helps this channel reach more curious minds. And hit the bell, because the 3rd pillar is coming, and it will change how you see everything. Until then, reason sharply, observe precisely, think deeply. Deductive minds, reason sharply, observe precisely, think